Hello children, I hope you're all doing well. So welcome back to our physics class. In today's class, we shall have some discussion on an interesting topic, that is Newton's third law of motion. So here we go with. So Newton's third law, the statement is as follows. To every action, there is an equal and opposite reaction. I repeat, for every action, there is an equal and opposite reaction. Okay, so I am stressing upon two terms. One is action and the other is reaction. Okay, to every action, there is an equal and opposite reaction. So these two terms, action and reaction, always acts in pairs. But remember that this action and reaction always acts in two different bodies, not on single body. Okay, so this always, the action and reaction pairs always acts in pairs, that means acts together but on two different bodies. That means action is always equal and opposite to the reaction force. Okay children? So action and reaction are always equal and opposite, that is action is equal to magnitude of reaction but in opposite direction. Okay children, so in order to understand this in a clear way, we have to consider a simple example. So let us consider a block of mass m is kept on a ground or floor. It's very clear that here we can observe two different bodies. One is the block of mass m, the other is the ground floor. So when this block of mass is whenever it is being kept on the floor, it exerts some force on the ground because of its own weight, and that force is given as weight, which is equals to mg. So W equals to mg. This is the action part. As the block is being kept on the ground, it exerts some force on the ground in downward direction. This is an action part. As a reaction, as the block is applying some force on the ground, because of some reaction, the ground also exerts an equal amount of force on the block but in the opposite direction. So action and reaction, equal amount of magnitude but direction is opposite. The force exerted by the block on the ground is in mg in downward direction, but the force exerted by the ground on the block is equals to mg, equal to the same amount, that is mg but in the opposite direction. So clearly mg downwards, mg upwards, direction is opposite but magnitude is mg. So the action means force exerted by the block on the floor. Reaction means force exerted by floor on the block. Both are in opposite direction. Isn't it clear children? So it's very clear that these two are acting together but on two different bodies. But if the same block is kept in air, then what you observe is, so there is no reaction force, only that the block is not exerting any force on air, means it's simply hanging, it's kept in the air if it is possible. Okay, so there is no reaction force, that's it. Okay, so only when it is kept on the ground, two different bodies if you consider, one part is action, the other part is reaction. So what Newton's third law says means for every action there is an equal and opposite reaction, and this action and reaction acts on two different bodies. Okay, and these two are equal and opposite. Action and reaction are equal and opposite, equal in magnitude but opposite in direction. This is the best example. The action part is the block acting, the action is the force exerted by the block on the floor, so it's action. The force exerted by ground on the block in the opposite direction is reaction. So here you can also go with one more example which was given in your material. So that means two springs they have considered. One spring was named as A, the other spring was named as B. Both the springs are being attached together, something like this. If this A is being pulled with some force, say A, 5 newtons, then this spring, the other spring, because they both are interlinked each other, this tried to pull the same, and here also you can observe 5 newton. That means if action part is A, reaction part will be on B. If it is applying 5 newton, here also it applies 5 newton. Simultaneously, if you observe that, both shows the same reading, that is 5 newtons. Okay, children? So this is a normal example you can consider in your lab. So based on that, let us try to one more concept I would like to explain you, children. So what exactly we are confused with the help of the Newton's third law is, what is the actual concept means action and reaction, they never cancel each other, because action is acting on one body, reaction is acting on another body. So how come they cancel each other? Though equal and opposite, but they never cancel each other, because they both act on two different bodies, not on same body. Hence we can never cancel action and reaction bodies. So what we confuse generally is the action and reaction forces are acting on a body, are equal and opposite, and hence they cancel each other. No. So they can never cancel each other, because they act on two different bodies. Okay, children? And one more concept what you need to know is, only those pairs forms an action-reaction pair which involves the two bodies responsible for action-reaction pair. Earlier I told you an example, no, that block of mass has been kept in air. Then only one body is possible, that is only block of mass. Okay, so this can't exert any force on that air. Okay, so here we always require two different bodies, not a single body is not possible. So any pair of equal and opposite forces only then forms an equal and opposite pairs. Okay, so single body is not possible. So anyhow, based on that, let us move to the numerical part of this. So first numerical, the action-reaction force referred in Newton's third law of motion. So what is the action and reaction part we have considered in generally the Newton's third law of motion? Do they act on the same objects? May act on different bodies? Must act on different objects? Or need not be equal in magnitude, but have the, no, not this. Must act on the same objects? No. Must act on different bodies? Must act on different objects. Yeah. So what makes the difference? Small grammatical mistake. So may act, must act. What is the correct, children? May means may be possible, may not be possible. Either of that you can take. So is it definitely make sure that whether two different objects are compulsory required, or it can be required or cannot be required. So it is compulsory, okay, mandatory. That means two different objects must be there to form an action and reaction pair. They must be there. So may, you can't take it as may. So the only correct option is third option. The action-reaction forces referred in Newton's third law of motion must act on different objects. Must act on different objects. Then only Newton's third law has been applicable. So third option is a correct answer. Moving to the next question, the law which gives the properties of forces. Yes, regarding the forces, which is one force, the other force, action force, reaction force, which law is telling? So Newton's second law only defines the formula, gives the formula, defines what is force. Force means F equals to ma, Newton's second law. Newton's first law, what does it say? Every body continues to be in state of rest or uniform motion unless it is acted by an external force. But what Newton's third law says means action force, something, it discusses something regarding the action force and the reaction force. So which law tells us or gives us the properties of force is nothing but Newton's third law of motion. Hence your right option is third option. Newton's third law of motion gives the properties of forces. So how the forces are acting, which direction, everything. Moving ahead, the earth attracts a stone towards itself with a force of 10 Newton. How much force have they given? With the 10 Newton force, the earth is pulling down the stone. then the force with which the stone attracts the earth is, if this happens to be the action part, then the other must be the reaction part. That means the stone also must attract the earth with the same force but in the opposite direction. So what is the force, children? 10 Newton. Which direction? Opposite direction. So here direction was not mentioned, only magnitude was mentioned. How much is the magnitude? 10 Newton, but in the opposite direction. So answer is third option. Next question. If action is 10 newtons, then reaction will be same thing. Action is 10, reaction is also 10, but in opposite direction. So 10 newtons, not in same. Here is your 10 newtons in the opposite direction. So your answer is third option again. So moving ahead, question number 5. Consider a porter standing on a platform. Porter, you know, that coolie, railway coolie, and also will be carrying all the goods and all luggages and all on his head. Okay, so a porter is standing on the platform. Some person, something, carrying a heavy load, say some suitcase over his head. Okay, children? Well, so consider a porter standing on a platform with suitcase which passes his head with a force of 200 newtons. So how much force is acting, the suitcase is acting, how much force ma? 200 newton on the head of the porter. Take this force as action. Then the reaction force is exerted by. So if the suitcase exerts a force of 200 newton on the head of the man, definitely what happens? The head of the man must act the same amount of force, that is 200 newton force in the upward direction. So the head must act on the suitcase. If the suitcase exerts 200 newtons on his head, the head also must exert 200 newtons on the suitcase. The head on the suitcase. Reaction force is exerted by the head on the suitcase. So first option is correct. Next question. A man at rest in the middle of a pond on a perfectly smooth ice. What is that? A pond is there. In the middle of the pond, an ice block is there, and this person is standing on the ice block. He can get himself to the shore. So he was standing on the ice block and he wants to get through the shore. He has to cross the pond. By making use of Newton's, which law is it possible? Newton's third law. Which law? Newton's third law. How means? For every action there is an equal and opposite reaction. So if the man wants to go forward, the ice will go opposite. Like so, if he jumps, like if he gives a force in this direction, then ice block will be moving in the ahead direction. So because of that force, he could able to get out of that pond. Okay. So action part on the block, and if he pushes the block backside, the block may push him forward direction. Action part and reaction part, so that he can get off the shore. Okay, children. So right option is third law. And now the next question. In case of a book lying on a table, book is lying on a table. Action of the book on the table and reaction of the table on book are equal and opposite are inclined. What do you mean by inclined, children? Something like standing. So no. So they are not inclined. They are not inclined. Okay. Action and reaction are equal and opposite. Of course, action and reaction are equal and opposite, but they are not inclined and perpendicular to the surface of contact. See, children, if you keep like the book is being lying on this, then if you think that this is the surface and this happens to be the book, this is your book, then to the surface, how the book direction is, this is your action part and this is your reaction part. So how they are? So action is for the surface, action part is in perpendicular direction, even reaction part is also in the perpendicular direction. So action and reaction are equal and opposite and act perpendicular to the surfaces of the contact. Yes, very true. Second option is true. Action and reaction are equal but act in the same direction. No, not in the same direction. They act in opposite direction. Action and reaction are not equal but opposite direction. They are equal. So fourth option is wrong, third option is wrong, first one is also wrong. They won't be in inclined position. So they will be perpendicular to each other. The surface and the action and reaction are perpendicular to each other. Now, next, whenever an object A exerts a force on another object B, A is exerting force on a B, then B must also exert force on A, but in the opposite direction. So then object B will exert a return force back in the object A. Yes, true. The two forces are, how are the two forces? They both are equal and opposite. So where is the correct answer? Equal in magnitude but in the opposite direction. Not same. They must be opposite direction. Equal in magnitude but opposite direction. Hence second answer is true. Not equal. No, they are equal. So this and this, they must be equal. So only among the two, because it is in the same direction, you have correct option is opposite direction. Action and reaction are equal in magnitude but opposite in direction. So next children, when we kick a stone, we get hurt. So when we kick a horn with the kicking, you know, no? So just kick the stone up. Definitely we get the hurt, isn't it? Yes sir, you people may be strong enough that you may not get hurt, but whenever we common people hit a stone, definitely we get hurt. Why? Because the hitting the stone is the action part. So as a result, the stone also hits us in the backward direction. So that is reaction part. So definitely we get hurt. So when we kick a stone, we get hurt. Due to which one of the following properties of stone? It happens because of the reaction part. We hit the stone is an action. Stone hits us to get hurt is a reaction part. So ninth option is third option. Okay children. So with this we have conclude the Newton's third law. Okay, and their applications, and let us the examples of Newton's third law of motion. Before starting with, let us recall back the Newton's third law of motion. What is Newton's third law of motion, children? Yes, to every action there must be an equal and opposite reaction. I repeat, to every action there must be an equal and opposite reaction. So coming ahead, let us continue with the examples. Suppose whenever a bullet is being fired, the bullet moves forward because the trigger of the gun applies certain force on the bullet, and this is generally considered as the action part. But according to Newton's third law, for every action there must be an equal and opposite reaction. So as a reaction part, the bullet applies an equal and opposite force on the gun backwards, and hence the gun recoils backwards by giving a jerk on the shoulder of the human. Moving to the second example, if you observe the jet aeroplanes and rockets, the fuel inside the engines of the jet aeroplanes or rockets are being burnt, and as a result hot gases are ejected from the nozzle of these engines in backward. Okay, so the hot gases will come out of the nozzle with high speed, with a large amount of force in the backward direction. Okay, and this is considered as an action part. As a result, the reaction part is nothing but these gases will apply an equal and opposite force on the engines of the jet aeroplanes or rockets, and as a result these engines, these rockets or aeroplanes will move forward. Okay children, so the action part is the hot gases will release out of the nozzle in the backward direction. Okay, this is an action part, and as a reaction part, these aeroplanes, jet aeroplanes or rockets will move with high speed in the forward direction. So this also based on the Newton's third law of motion. Now coming to the third example. If you observe a person swimming, okay, a person whenever he will be swimming, he applies some amount of force with his hands on the water, and with that force he will be pushing the water backwards with his arms. He will be pushing while swimming. The person will push the water backwards. This is an action part. As a reaction part, the water pushes the man forward, and hence the swimming is being carried. So action part is a man pushes the water backwards is an action part, and reaction part is water pushes the man forward, and hence swimming is possible. The man moves in the forward direction. Similarly, if you go with one more example, walking. Walking is also possible based on the Newton's third law of motion. While walking, what you observe is the foot of a person will pushes the ground in the backward direction. While walking, we push the ground in the backward direction. And this is an action part, and as a reaction part, the ground exerts an equal and opposite force on the foot of the man, and hence walking is possible. So the action part is pushing the ground backwards is an action part, and the reaction part is the ground applies an equal and opposite force on the foot of the man, making him to move forward. This is a reaction part. So this is also based on your Newton's third law of motion. Now coming to one more example, while rowing a boat. You know, the oars boat will be there, so like this we will be rowing. So in order to row a boat, we require the large sticks called oars. So with the help of the oars, we will be pushing the water backwards. As a result, the water will push the boat forward. So action part is pushing the water with oars in the backward direction is an action part, whereas as a reaction part, the water will push the boat in the forward direction, and hence the boat will move forward. So with these examples, we can conclude that for every action there is an equal and opposite reaction, and nothing but it is a Newton's third law of motion. So these are the examples we have considered. A gun recoils whenever, recoils means moving backwards, okay, whenever a bullet is being fired. So whenever a bullet moves forward, the gun gives a backward jerk. Next example, jet aeroplanes and rockets. So hot gases will come out from the nozzle as an action part. As a reaction part, the rocket starts moving forward. Similarly, while swimming, a person moves forward while swimming. Why? How? Because the swimmer pushes the water in the backward direction, and the water pushes him in the forward direction. Similarly, while walking, the person pushes the ground with his foot in the backward direction, whereas as a reaction part, the ground pushes the man in the forward direction, and hence walking is possible. Similarly, while rowing a boat, with the help of oars, we push the water backward direction. As a reaction part, the water will push the boat forward. So based on that, we can continue with the numerical part of the Newton's third law of motion. So let us move to the worksheet number 7. So first numerical. So if a man jumps out from a boat, so what he is doing is, a man jumps out from a boat. That means he will be jumping forward. So whenever this is an action part. So whenever he moves forward, what happens to the boat? As a reaction part, the boat must move backward direction. Okay. So a man jumps out from a boat, then what happens to the boat? The boat must move in the backward direction. So which is the correct option, children? Third option. Hence, your correct option is backward direction. Man moves forward, reaction part, the boat moves backward. Moving to the second numerical. While flying, the bird pushes the air. So whenever the birds are flying, they flatter. Okay, they flatter their wings. So they up and down, they will flatter the wings. Whenever they are flattering the wings, they push the air downwards. Okay, so the air is being downwards and the bird will fly high. So while flying, the birds push the air in which direction, children? Downward direction, and hence the bird will fly up. So option number 2, the air is pushed downwards. Next question, next numerical. Rockets work on the principle of which law? So rockets and jet aeroplanes work on the principle of Newton's third law of motion. To every action there is an equal and opposite reaction. That means the gases will come out, action part, and reaction part is the jet planes and rockets will move forward. Hence it is based on the Newton's third law of motion. So option number 3. Next, question number 4. A jet engine works on the principle of, just now we have discussed that either jet aeroplanes or rockets work on the principle of Newton's third law of motion. So option number 3. Now, last question. Swimming is possible on account of first while swimming also. So what principle or what law is being applied? Newton's third law of motion. How means the swimmer will pushes the water backwards. This is an action part. and as a reaction part, the water pushes the man forwards, and hence the swimming is possible. So for every action there is an equal and opposite reaction. So this is based on the Newton's third law of motion. So swimming is possible on account of Newton's third law of motion. So option number 3. So with this we conclude the numerical part of this concept number 7. Okay children. So thank you for your attention, and let us meet in the next class. Thank you.